Thank you for your purchase. Welcome to the AI Ascendance. The era of neo-intelligence begins now. A deep dive into AI in 2024 by Roni Everleaf, narrated by Benjamin K. Shillings, a publication by Intercontinental Digital Matrix Publishing. Copyright 2023. This is an Intercontinental Digital Matrix Publishing audiobook. The AI Ascendance. The era of neo-intelligence begins now. A deep dive into AI in 2024 by Roni Everleaf, narrated by Benjamin K. Shillings, a publication by Intercontinental Digital Matrix Publishing. Note to reader, the author assumes no liability for the reader's decisions and/or use of information in this book. Readers retain full responsibility for all outcomes resulting from their actions. This book is provided as is. Preface. As the sun sets on the third decade of the 21st century, we stand on the precipice of an era unlike any we have ever known, an era where the culmination of our technological pursuits begins to softly echo the intelligence that nature has spent millennia perfecting. This book, The AI Ascendance, is more than a witness to this transformative period. It is a guide, a chronicle, and a conversation about the era of neo-intelligence that begins in 2024. My journey with artificial intelligence began not as a technologist, but as an observer of human nature. I was fascinated by our ceaseless quest to replicate and enhance our cognitive abilities through machines. Like many, I approached AI with a cocktail of curiosity and caution, enthusiastic about its boundless applications, yet vigilant about the potential ethical quagmires. With this book, I invite you to traverse the expansive and multifaceted realm of AI. The following chapters are crafted to carry both the enlightened and the uninitiated through the labyrinthine developments that have brought us to the present moment and will propel us into the future. Each page distills years of research, impassioned debate, and insights from pioneers who have planted the flags of human intellect on the digital frontiers. Why focus on 2024, you may ask? While AI's evolution is continuous, there are inflection points where the convergence of technological breakthroughs, societal readiness, and economic impetus creates waves that reshape our reality. 2024 represents such a watershed moment. In writing this work, I consulted with a diverse cadre of experts, scientists, philosophers, ethicists, and educators, to present a narrative that is as comprehensive as it is accessible. The AI Ascendance is not only about the state of AI, but also about its relationship with us, how we influence its trajectory, and how it in turn redefines aspects of our existence, from the way we work to the complexity of our ethical frameworks. What emerged from my conversations is a tapestry reflective of AI's duality, its power to create and disrupt, to liberate and challenge. This duality is central to our dialogue as we explore topics ranging from algorithmic marvels and autonomous systems to the nuanced human concerns that emerge from a more intelligent tomorrow. I offer this book to you, the reader, as a lens through which to perceive the AI landscape. Whether you seek to harness AI's potential, understand its implications, or simply explore its wonders, you'll find the AI Ascendance a valuable companion. It is my sincere hope that the chapters that follow will not only enlighten, but also inspire you to participate in shaping the era of neo-intelligence as it begins to unfurl. Join me as we embark on this journey of discovery. Prepare to dive deep into the nuances of the technology that has captivated the world's imagination and grapple with the profound changes that AI is set to bring in 2024. The time is ripe for reflection, for anticipation, and for action. So let us turn the page and begin the ascent into an AI-augmented horizon. Roni Everleaf. Chapter 1. Introduction to Artificial Intelligence. In the 21st century, when we dream of the future, we envisage a world shaped by the wondrous and often surreal advancements of artificial intelligence, AI. No longer confined to the pages of sci-fi novels or the reels of Hollywood blockbusters, AI has become a tangible, integral part of our society, a catalyst for innovation and growth. Entering the realm of AI inviting you into the comprehensive and engaging narrative of AI, this book provides a panoramic view of its expansive landscape. As a testament to human ingenuity, AI represents not just a set of technologies, but a new epoch in our civilization's development. In this introduction, we will prime the canvas on which this exciting story will unfold, examining the most fundamental questions. What exactly is AI? Why is it so important to the modern world? And how does it play a pivotal role across the various spectrums of human endeavor? 1.2. Defining artificial intelligence. Artificial intelligence, in its essence, is about creating machines that can perform tasks that would typically require human intelligence. This includes the ability to learn from experiences, understand complex concepts, engage in various forms of communication, and respond to changes in their environment. To bring AI to life, innovators have fostered fields such as machine learning, where algorithms are not just coded to perform specific tasks, but are equipped to learn from data and improve over time. AI incorporates a rich tapestry of concepts, from the pattern recognition abilities of deep learning to the decision-making prowess of predictive analytics. 1.3. The broad impact of AI. Artificial intelligence has embedded itself into the framework of various industries, fundamentally altering the landscape of what is possible. It streamlines processes, increases efficiency, accelerates research, and personalizes experiences. Imagine the intricate network of global logistics optimized in real time, life-saving medical diagnoses rendered with supreme accuracy, or personalized education materializing from the wealth of human knowledge. These are no longer aspirations. They are real-world implementations of AI. 1.4. Debunking the myths. AI often conjures images of rogue machines and dystopian futures, but the truth is considerably different. AI does not exist to replace humanity. It exists to augment it. Through this book, we will dispel the myths, clarify the sensationalism, and lay out the factual landscape. By understanding what AI is and what it isn't, we can engage with this technology from a place of knowledge and reason, not fear and misconception. 1.5a. Look into the future. As we contemplate the horizon, it is clear AI will continue to evolve. Self-driving cars, smarter healthcare, seamless interaction with devices through voice and gesture, these are just the beginning. The integration of AI in our daily lives will progress, making way for more nuanced interactions and learning. This book will not only guide you through the present state of AI, but also provide insights into potential future developments. 1.6. Ethical considerations and humanistic perspectives. Any discussion on AI is incomplete without addressing the ethical implications. Issues of privacy, autonomy, job displacement, and AI biases are of paramount importance. We will navigate the interplay between AI advancements and their societal impacts, offering a platform for informed discourse on how we can shepherd AI development with conscientious governance and ethical principles. 1.7. The audience and purpose of this book. Whether you are entirely new to the concept of AI, a seasoned professional looking to gain new perspectives, or a policymaker pondering the ramifications of AI deployment, this book is crafted for you. We aim to deliver a multidimensional understanding that transcends technical jargon, providing a clear, accessible entry point into the world of AI. To educators and students, this book serves as an educational guide. To entrepreneurs and business leaders, a compass for strategic decision-making, and to the curious and the skeptical, a source of enlightenment and reasoned argument. 1.8. Journey through the chapters. As we voyage through the chapters, we invite you to familiarize yourself with the historical context, foundational theories, and practical applications. Marvel at the unjust technological advancement. Ethical considerations should be interwoven with AI from the drawing board to the society at large, fortifying trust, inclusion, and prosperity. The AI journey encapsulates not only extraordinary innovation, but also profound responsibility. It stands not merely as a testament to human ingenuity, but as a beacon for humanity's moral compass in the steadfast evolution of artificial intelligence. Chapter 7. The data behind AI 7.1. Importance of data in AI. Data is often referred to as the fuel for artificial intelligence, AI. To understand why this analogy holds true, one must firstly acknowledge that AI systems, particularly those based on machine learning, need vast amounts of data to learn, reason, and make decisions. Much like fuel powers engines, data powers AI algorithms, enabling them to discern patterns, make predictions, and adapt to new situations with minimal human intervention. At its most foundational level, data allows AI systems to simulate the way humans learn, transforming experience into expertise. For instance, the more data an AI algorithm processing facial recognition is exposed to, the more accurate it becomes at distinguishing faces. This capability is possible because, with each new data input, the AI refines its parameters incrementally, optimizing its predictive accuracy. Another important aspect is the diversity of data required for robust AI systems. Disparate data points from various origins, demographics, and types contribute to the creation of more holistic and inclusive AI models, which are less prone to bias and misunderstanding. Having a plethora of data from different sources ensures that AI systems can perform well across various settings and domains, increasing their reliability and utility. Moreover, not just any data will suffice. The quality of data is crucial. High-quality data is characterized by accuracy, completeness, relevantness, and timeliness. Poor quality data can lead to erroneous outputs, even if the AI models are sophisticated. This underscores why data integrity is essential for AI's effectiveness. A common maxim in the field states, "Garbage in, garbage out." This succinctly captures the predicate that the success of AI depends on the initial input data's quality. Feed an AI system inaccurate or biased data, and the output will be equally flawed. In a world increasingly reliant on AI-driven decisions, this underpins the magnitude of obtaining high-quality data. 7.2 Data collection methods. The ubiquity of digital technology has enabled various methods for data collection, each with its own advantages and applications within AI. Historically, data came from painstaking manual collection, surveys, observational studies, and paper records. Today, the landscape of data collection is more sophisticated and digitized. One primary method includes data scraping from the internet, which provides a massive repository of text, images, video, and audio resources. For example, social media platforms are treasure troves for sentiment analysis and consumer behavior prediction algorithms. Another significant source is sensor data, critical for industries reliant on real-time monitoring like transportation, healthcare, and manufacturing. Innovations like the Internet of Things, IoT, have dramatically expanded the types and quantities of sensor data available. Additionally, transactional data following economic activities and interactions are valuable to AI models that predict market trends or customer preferences. Massive datasets can now be processed from point-of-sale systems, online checkouts, and stock trading activities. Crowdsourcing is another method, where numerous users or volunteers collectively gather and share data. This method proves its mettle in projects that benefit from human experience and cognitive skills, often outpacing tightly controlled and individually staffed projects. Moreover, augmented data collection methods using augmented reality, AR, and virtual reality, VR, are making waves, creating high-fidelity simulations that produce predictive data for use in various industries. Despite the progress, it's imperative that the methods employed for collection adhere to ethical standards, ensuring the safety, consent, and privacy of individuals involved. 7.3 Data privacy and security. Hand in hand with the collection of data comes the significant responsibility of safeguarding it. Data privacy and security are among the top concerns in the era of big data and AI. The conversation involves ethical considerations regarding what data is collected, how it's used, and who has access to it. With stricter regulations like the General Data Protection Regulation (GDPR) in Europe or the California Consumer Privacy Act (CCPA) in the United States, the focus on protecting personal information has never been sharper. AI developers and data scientists are obligated to ensure personal data is anonymized, consent is obtained, and data usage is transparent. Security measures must be robust to prevent unauthorized access, data breaches, and potential exploitations of sensitive data. State-of-the-art cryptographic techniques, access control, and consistent security audits are employed to guard this data. In the context of AI, preserving privacy becomes even more complex, as models may inadvertently reveal personal data through inference attacks. Differential privacy is one approach gaining traction, offering a way to gain insights from datasets while mathematically guaranteeing individual privacy. Understanding the interplay of AI systems and data privacy is fundamental not only for compliance and avoiding reputational risks, but also for maintaining the trust of the end users whose data and livelihoods may be at stake. 7.4. Data processing and management. Transforming raw data into a format that is usable for AI systems involves several phases of data processing. The first step is often data cleaning, which involves removing inaccuracies, duplicates, and irrelevant information. The subsequent process of data integration may be applied where data from disparate sources are combined into a unified set. The ascendance of big data technologies has modernized data management. Tools like Apache Hadoop and Apache Spark facilitate distributed storage and processing, handling large-scale data management tasks previously deemed impractical. Effective data management should also ensure that the processed data is stored securely, organized for retrieval, and catalogued for use in various AI models. Metadata management is essential, enabling data scientists to understand the data's origin, format, and context, thus improving the efficacy of data in training AI models. Moreover, database technologies such as NoSQL databases or data warehouses are optimized to handle the structured and unstructured data varieties that AI technologies often necessitate. Acquiring, storing, and managing data will increasingly challenge organizations as data volumes continue to snowball. Yet the advancements in big data technologies continuously empower the development and success of AI systems. 7.5. Big data and AI. One cannot underplay the role of big data in the accelerated growth of AI. Big data refers to the voluminous datasets that are too large or complex for traditional data management tools to handle. The enlightening aspect of big data is not just its size, but the deep insights that can be extracted through analysis. AI's deep learning branch, encompassing algorithms modeled after the human brain, requires copious amounts of varied, quality data. Big data provides the needed range and volume, and when processed efficiently, it allows these algorithms to discern complex patterns. This synergy has led to breakthroughs in fields like genomics, climate modeling, and real-time language translation. The relationship between big data and AI is synergistic. Not only does AI require big data to improve, but big data technologies increasingly employ AI to analyze and derive value from the data. This mutual reinforcement loop is expected to proliferate as both fields evolve. Analytics powered by AI also provides an edge to businesses by translating big data into actionable intelligence. Predictive analytics, for instance, uses past data to foresee future trends, allowing organizations to make more informed decisions. As big data expands and becomes more intricate, AI's computational prowess and adaptivity will be paramount in utilizing these vast datasets to solve the world's complex problems. In reflection, this chapter has demonstrated that data, its collection, management, privacy, and its expansive volume known as big data, is crucial for AI's current and future landscapes. The symbiotic relationship between AI and data prompts a continuous cycle of improvement and innovation, unlocking unparalleled capabilities across various sectors. Ultimately, the proficiency of AI systems hinges on well-curated and managed data, leading to the dawning reality described as an AI-driven world. As we proceed toward that horizon, our knowledge leveraged today will shape the success of AI tomorrow. 8. AI development and lifecycle. Artificial intelligence is a swiftly evolving field, changing the way we interact with technology and interpret data. But how exactly do these advancements come to fruition? The AI development and lifecycle is a critical phase that encompasses everything from the initial project design to the continuous maintenance after deployment. In this in-depth chapter, we will explore the nuances of AI project planning and management, the structuring of an AI team, the actual development process, as well as the testing, validation, deployment, and maintenance of AI systems. Chapter 8. AI Development 8.1. AI Project Planning and Management. AI project planning and management begins with setting clear objectives and understanding the limitations and requirements of your AI project. It involves multidisciplinary coordination, considering the intricate interplay between software development, data infrastructure, model training, and business applications. To start, experts must draft a project charter, which outlines the goal of the AI project, stakeholders and their roles, the scope of the AI systems being developed, resources required, including talent, data, hardware and software, risk identification and management strategies, a timeline with milestones and deliverables, effective project management techniques tailored for AI, such as agile or hybrid models, ensure flexibility and adaptability in what is often unpredictable development terrain. Project managers encourage iterative improvements, frequent assessments, and fine-tuning, thereby achieving optimal performance and functionality of the AI application. 8.2. Building an AI team. Roles and responsibilities. Assembling a multidisciplinary AI team is crucial to maneuver through project complexities and challenges. With expertise from various domains, this team combines skills to cover the entire spectrum of the project's needs. Crucial roles often include data scientists. They are the mathematicians and statisticians capable of interpreting complex data, developing algorithms, and applying machine learning techniques. Machine learning engineers. These experts specialize in implementing these algorithms at scale, ensuring they function within software applications. AI researchers. Keep the team updated on the latest scholarly work and incorporate cutting-edge techniques into the team's workflow. Data engineers. Vital for constructing data pipelines, they guarantee that the data is clean, comprehensive, and accessible. Project managers. They keep everyone on task, ensuring deliverables are met on time and within budget, providing the glue that holds the project together. Business analysts. With a thorough understanding of the business implications, they ensure that AI projects align with business goals and deliver value. UX designers. Often overlooked, they ensure the accessibility and usability of AI applications, especially if they interact directly with users. Building a team with clearly defined roles and responsibilities fosters an environment conducive to effective collaboration and innovation. 8.3. The AI development process. The development of artificial intelligence can be broadly conceptualized as a complex, iterative process consisting of the following predominant phases. 1. Requirement gathering. Deciphering and documenting what needs to be accomplished by the AI system. 2. Data collection and processing. Securing a quality data set suitable for training the machine learning models and ensuring it undergoes pre-processing to improve its utility. 3. Prototyping. The creation of simple models to test assumptions and baseline performance. 4. Feature engineering and model development. Expanding the prototype by refining or developing the algorithms to increase the robustness and accuracy. 5. Continuous integration and deployment, CI/CD, using these methodologies to ensure code and model updates flow smoothly from development to production. 6. Testing and validation, rigorously assessing the model to gauge its performance and making necessary adjustments to improve it. The tight integration of development activities, when accompanied by a thorough documentation practice, paves the way for transparent and replicable AI models. 8.4. Testing and validating AI models. Testing and validating AI models are pivotal to ensure they make accurate predictions and are free of biases. This involves dividing the available data into training, validation, and testing sets. Performance metrics must be carefully selected based on the type of problem, anomaly detection, classification, regression, since they provide insight into the quality of the model. Techniques such as cross-validation, where multiple subsets of data are used for training and validation, help in reducing overfitting and ensuring the model generalizes well to unseen data. Furthermore, it's essential to test AI models against real-world scenarios, accounting for variable conditions and operational contexts they are likely to encounter after deployment. Beyond accuracy, it's crucial to examine models for fairness and robustness through testing methodologies like adversarial testing, interpretability analyses, and bias checks. Measure progression towards completion involves continuous monitoring of a set of defined metrics. 8.5. Deployment and maintenance of AI systems. The deployment stage transitions a developed AI model from a controlled development environment to the unforgiving reality of the production stage. It demands meticulous preparation, whereby the model must be packaged with its dependencies, tested across various environments, and provisioned with continuous monitoring to track its performance under operational conditions. Once live, the AI system requires routine upgrades for model improvements, code, or platform changes. The systematic collection of data on its operation can spark enhancement, leading to the model being retrained to accommodate shifts in the underlying data it processes. Regular checks ensure that security protocol adherence remains unhindered and that model performance does not degrade, known as model drift. To add, setting up automated processes to handle deployment and maintenance tasks reduces human error and ensures that the AI system remains functional, secure, and as accurate as the day it was first deployed. In summary, while the path of AI development and lifecycle is not without its perils, filled with technical hurdles, evolving requirements, and the juggling of various stakeholders, it is an essential component of what will become not just functional, but pioneering AI systems. Being diligent with the planning, adept at the team assemblage, meticulous during development, relentless in testing and validation, and vigilant throughout deployment and maintenance, embarks an AI project on the road to success, ready to transform and propel industries and societies forward. Chapter 9. AI and Society. The profound impact of artificial intelligence, AI, on society encompasses a variety of domains, from the way we work and learn to how we interact and govern. As this wave of technology advances, its footprint on societal fabrics becomes more nuanced and significant, sparking conversations about the role AI should play in our future. 9.1. The impact of AI on society. AI's infusion into daily life has led to both subtle and prominent shifts in social dynamics. Automation powered by AI has reinvented industries, leading to increased efficiency but also to concerns over job displacement. Despite fears of automation replacing the workforce, AI often creates new job opportunities and demands for skills in areas such as AI maintenance, development, and ethical management. The adaptation of AI in various sectors has improved convenience and personalization, creating bespoke experiences for users. In healthcare, AI-powered diagnostic tools aid in detecting diseases with precision and speed that was once unattainable. In education, personalized learning platforms adapt to the proficiency and pace of the student, while in urban planning, AI algorithms optimize traffic flow, reducing congestion and pollution. Nonetheless, as AI technology grows more entrenched, the digital divide raises concerns. Essentially, this divide is a gap between those who have or do not have access to modern information and communication technology, and AI intensifies this by potentially excluding those without digital literacy from the full benefits it affords. 9.2. AI for social good and humanitarian efforts. AI's capability extends beyond commercial interests and also includes the potential for significant contributions to social good and humanitarian efforts. It can help address grand challenges, including poverty, hunger, and disaster response. By analyzing vast quantities of data, AI systems can identify patterns and make predictions that can improve agricultural yields or pinpoint areas at high risk of famine. During disasters, AI systems facilitate faster and more efficient responses by optimizing rescues and delivering supplies, often in coordination with drone technology. In public health, AI aids in outbreak prediction and the tracking of disease diffusion through complex analytics, potentially saving thousands, if not millions, of lives. It also democratizes access to medical expertise by establishing telemedicine in remote areas lacking sufficient healthcare providers. AI-focused social enterprises have demonstrated a growing commitment to ethical applications that benefit humanity while safeguarding rights and privacy, signaling a conscientious direction for AI. 9.3. Public perception and acceptance of AI. The public's perception and acceptance of AI vary widely. While there is excitement about the possibilities, concerns regarding data privacy, security, and the ethical use of AI temper optimism. The Black Mirror-esque scenarios, painted by speculative fiction and media reports on AI misadventures, have had an undeniable impact on the public mind. It's vital to differentiate the facts from hyperbolic myths surrounding AI to garner informed acceptance. Ongoing education and transparent dialogue between AI innovators and the public can alleviate entrenched fears. A collective understanding that AI, like any other tool, relies significantly on the principles scripted by human creators may ease apprehensions surrounding its application. Policy can be a bridge to public understanding and trust in AI. By instituting standards and oversight, policymakers can alleviate fears of unchecked AI. Academic and industry partnerships with authorities, may further foster an environment where the public can view AI as an ally rather than an adversary. 9.4. AI in governance and policymaking. AI's influences are also palpably felt in governance and policymaking spheres. Its knack for processing vast troves of data can inform policy decisions with enriched insights and forecasts, shifting governance from a reactive to a proactive stance. AI systems afford governmental agencies the opportunity to streamline operations, trim costs, and enhance public services. Increasingly, countries are exploring AI for e-governance platforms that improve service delivery and citizen engagement. However, the implementation of such technologies raises important questions about surveillance, citizenship privacy, and the ethics of algorithmic decision-making. In policymaking, AI can also buttress democratic processes by synthesizing public opinion from social media, forums, and other platforms, granting policymakers a more precise understanding of constituent demands and sentiments. However, this too is a dual-edged sword. Misinterpretation or manipulation of this data can erode public trust. As governments warm to AI's benefits, they also find themselves drafting regulatory landscapes to guide its ethical development and deployment. Thus, despite AI's transformative potential, it has invigorated a global conversation around regulatory frameworks, managing the risk associated with its societal integration. In summary, AI's interlacing with society has drastic implications for every individual and community. Recognizing AI's influence on social constructs is imperative for harnessing its potential for unprecedented benefits while keenly navigating its risks. The chapters that follow delve deeper into AI's advancements, their ethical ramifications, and how they interface with the journey of human progress. Chapter 10. The Future of AI. 10.1. Predictions for AI Advancements. As we stand at the precipice of technological innovation, artificial intelligence, AI, emerges not merely as a tool, but as an architect of a new era. In envisioning the future of AI, several advancements appear imminent and momentous. Machine learning algorithms are expected to evolve towards self-learning capacities, sort of an artificial general intelligence, AGI, surpassing the need for human-led training. With AGI, systems could tackle complex, multifaceted problems, offering solutions unforeseen even by their creators. Another sphere of anticipated advance is contextual AI. Unlike its predecessors, contextual AI interprets not just data, but also its meaning, thereby augmenting decision-making processes across industries, from finance to healthcare, by providing deeper insights. In the realm of autonomous vehicles, the road ahead includes solving the subtleties of human behavior and environmental unpredictability. Progress in this domain poses a seismic shift in transportation, potentially altering the urban landscapes and economies' magic around personal and public transport. Similarly, AI's role in personalized medicine can't be understated. Through advanced analytics of medical records and genetic information, AI shall enable highly tailored treatment regimens. This personalization will be the cornerstone of precision medicine, targeting the underlying causes of a patient's illness, far surpassing symptomatic relief. Lastly, language processing will stride towards fully understanding and recreating human-like natural language, becoming seamlessly conversant and context-aware, breaking cultural and linguistic barriers at an unparalleled scale. 10.2. The role of quantum computing in AI. Quantum computing stands at the frontier of expanding AI's capabilities. Its potential to process colossal datasets nearly instantaneously introduces unprecedented computational speed and efficiency. Quantum algorithms are poised to accelerate machine learning, optimizing complex models that would befuddle classical computers. The synergy between quantum computing and AI could transform fields such as cryptography, where quantum algorithms can rapidly factorize the large numbers central to encryption, challenging current data security paradigms. In tandem with this disruptive power, however, comes the promise of developing new, quantum-resistant cryptographic techniques. Furthermore, quantum computing may revolutionize drug discovery and materials science. By precisely simulating molecular interactions, AI-powered quantum computing could expedite the design of new compounds and substances, once an arduously time-consuming affair. Despite the promise, quantum computing is still embryonic in its practical application. AI is set to be integral in refining quantum algorithms and correcting quantum errors, aligning these quantum mechanisms more closely with real-world applications. 10.3. The convergence of AI with other technologies. What explicitly underscores the future of AI is not AI alone, but its convergence with other burgeoning technologies. The interplay of AI with the Internet of Things, IoT, and 5G technology would facilitate a network of seamlessly connected devices, allowing for smart environments where your fridge restocks itself and your house anticipates needs you haven't yet articulated. Similarly, combining AI with blockchain can bolster data security, enabling transparent, immutable records that benefit domains from supply chain management to voting systems. In addition, biotechnology marries AI to analyze and manipulate biological data, advancing gene editing, synthetic biology, and gargantuan strides in personalized medicine. The convergence with renewable energy technology could as well lead to more efficient and predictive sustainability models. The cornerstone of such convergence lies in the fact that AI does not live in isolation. It is the oxygen that breathes efficiency and foresight into various tech ecosystems. 10.4. Preparing for the AI-driven future. As we steer towards an AI-based horizon, preparation crystallizes as key. Corporations and institutions require strategic integration of AI into their businesses. A pivotal step involves fostering an AI-literate workforce conversant with machine learning principles and data analytics. Policymakers and educational institutions must respond with frameworks that nurture AI talent and research, while also safeguarding against destabilizing job displacement through upskilling and reskilling programs. On the infrastructural level, countries must invest in high-speed internet and interconnected devices, laying the foundational bedrock for AI applications to proliferate. 10.5. Final thoughts. Embracing AI responsibly. The whirling momentum of AI's evolution imparts an unspoken responsibility. Harnessing AI's full potential means not only celebrating its triumphs, but also vigilantly scrutinizing its impact on ethical grounds. Issues such as algorithmic bias must be relentlessly addressed, ensuring AI systems don't perpetuate societal inequalities. Transparency is the watchword here. AI's decision-making process should not be a black box, but an open book for scrutiny and understanding. In parallel to ensuring transparency, privacy laws must keep pace with AI's reach, protecting individuals' data from misuse. The growing field of privacy-preserving machine learning traits, such as federated learning, are steps towards this objective. Finally, regulations should embrace flexibility to adapt to AI's growth. Fostering innovation while ensuring safety, rights, and ethical accountability aren't forsaken. Embracing AI responsibly underlines an optimistic yet cautionary hymn, a melody of marvels entwined with mindful stewardship that shall compose the flourishing future of AI. Chapter 11. Case Studies and Real-World Examples. 11.1. AI Transforming Businesses. Case Studies. The impact of artificial intelligence on the landscape of business is nothing short of a revolution. Here we examine a variety of case studies where AI has fundamentally transformed operations, increased efficiency, and driven innovation across different industries. Retail personalization. Recommender systems in e-commerce. At the forefront is the personalized shopping experience offered by e-commerce giants like Amazon. Their recommender system is a paragon of machine learning efficacy, dramatically increasing user engagement by suggesting items based on browsing history, purchase records, and items in the shopping cart. Behavior is analyzed in real time, adapting recommendations to even the most subtle shifts in consumer preferences. Manufacturing. Predictive maintenance in automotive. In automotive manufacturing, companies such as Tesla have utilized AI to move towards predictive maintenance. By analyzing data collected from sensors on equipment, the AI system can predict when a machine part might fail. This preemptive approach saves millions in unscheduled downtime, not to mention the associated costs in repairing unexpected malfunctions post-breakdown. Supply chain optimization. DeepMind and Google data centers. DeepMind's AI has performed feats of supply chain optimization within Google's own data centers, reducing cooling costs by 40% through intelligent energy management. This AI system uses deep neural networks to predict future cooling needs and assess optimal conditions for energy consumption in real time. 11.2. AI in disaster response and prediction. artificial intelligence has also a role to play in the preventative aspects of disaster response and prediction, which requires the rapid processing of vast amounts of data to make life-saving decisions. Earthquake prediction, AI aiding seismologists. Startups such as Zismos are developing machine learning algorithms that work alongside sensors deployed around potential fault lines to detect early warnings for earthquakes. The algorithms analyze seismic data to predict tremors, providing precious seconds or minutes of warning that can save lives. Flood forecasting initiatives. Google's public alerts. Currently, Google, in collaboration with government agencies, incorporates AI into their public alerts. The systems analyze historical flood data and run simulations of river behavior to provide early warnings to at-risk populations, potentially minimizing property damage and averting loss of life. Wildfires. AI-assisted evacuation and containment strategies. Organizations are using satellite imagery processed by AI to identify hotspots indicative of wildfire activity. This real-time data supports firefighters to strategically deploy resources and aids in developing evacuation protocols to safeguard communities. Chapter 12. Resources and Further Learning. The trajectory of artificial intelligence, AI, is steep and continually rising, offering transformative possibilities across all sectors of society. The relevance and implications of AI are such that continuous education on the topic has become essential for professionals, students, and enthusiasts. This chapter is devoted to presenting you with a robust compilation of resources and learning materials designed to further enhance your understanding and engagement with AI. 12.1. Books and academic papers on AI. AI as a field is rich with literature ranging from introductory textbooks to complex dissertations covering myriad subdisciplines. Books serve as a foundational resource for those starting out or looking to gain deeper insights into particular aspects of AI. For beginners, books such as Artificial Intelligence, A Modern Approach by Stuart Russell and Peter Norvig provide a comprehensive introduction to the core concepts and algorithms shaping AI. Others, like Life 3.0, Being Human in the Age of Artificial Intelligence by Max Tegmark, offer a more exploratory look at AI's implications on the future of life on Earth. In academia, journal articles and conference proceedings provide cutting-edge insight into ongoing research and breakthroughs. Publications like Journal of Artificial Intelligence Research and Artificial Intelligence Magazine consistently feature peer-reviewed papers that foster both the practical and theoretical expansion of the field. Readers seeking an insight into more specific avenues of AI can explore texts such as Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Corville, which dive into complex neural networks and machine learning techniques. For a technical and ethical perspective, Weapons of Math Destruction by Cathy O'Neill is seminal, exploring how algorithms reinforce inequality. 12.2. Online courses and certifications. Due to the high demand for AI expertise, a multitude of online courses and certifications have been developed to cater to diverse learning needs and career stages. Platforms like Coursera, edX, and Udacity offer programs created by top universities and industry leaders, covering topics from fundamental AI concepts to applied machine learning and AI for business strategies. Coursera's AI for Everyone by Andrew Ng and Udacity's AI Nano Degree program are routinely acclaimed for their excellence and accessibility. Many of these courses are task-oriented and provide hands-on experience with AI technologies, essential for building a practical understanding of the field. Particular focus is given to mastering frameworks such as TensorFlow and PyTorch, which are vital tools for modern AI practitioners. 12.3. Conferences and workshops. Conferences and workshops remain fundamental for professionals seeking to stay abreast of rapid developments in AI. Events such as the annual Neural Information Processing Systems, NeurIPES Conference, and the International Conference on Learning Representations, ICLR, showcase pioneering research and facilitate discourse among academia and industry giants. Workshops often run in tandem or as part of larger conferences, offering more intimate settings for discussion, collaboration, and detailed presentation of AI topics. Attending these events not only provides exposure to novel research, but also opens networking opportunities, essential for career growth and collaboration in AI advancements. 12.4. leading AI research institutions. Numerous academic institutions and research labs across the globe are at the vanguard of AI research. Entities like the Massachusetts Institute of Technology, MIT, Stanford University, the University of Cambridge, and ETH Zurich have dedicated departments and initiatives focused solely on advancing AI. Furthermore, corporate research divisions like Google's DeepMind, OpenAI, and Facebook AI Research, FAIR, are producing influential work in the field. These organizations not only contribute groundbreaking research, but also frequently release resources, datasets, and tools that serve the wider AI community. 12.5. Online communities and forums for AI enthusiasts. Online communities and forums offer invaluable spaces for discussion, troubleshooting, learning, and the exchange of ideas among those interested in AI, irrespective of their proficiency level. Noteworthy examples include the subreddit r/machine learning, which encourages a technical and academic focus, and Stack Overflow, where real-world problem-solving with AI takes center stage. Other platforms, such as AI Stack Exchange, focus solely on AI-related queries, while GitHub provides repositories hosting an array of AI projects which are open for contributions. Additionally, LinkedIn groups and Twitter threads often feature debates and dialogue from thought leaders in AI. Engagement with these communities facilitates an interactive learning experience, enabling enthusiasts to share insights, keep pace with advancements, and glean knowledge from peers and experts alike. In closing this comprehensive outline of resources, it becomes evident that the quest for AI knowledge is a dynamic and continuous process. Books, papers, courses, conferences, research institute, tie-ins, and online communities collectively form the intellectual ecosystem, fostering the study and growth of AI. The commitment to further learning and understanding in this expanding field will be instrumental for anyone who seeks to be part of the ever-evolving narrative of artificial intelligence. Chapter 13. Conclusion. 13.1. Recap of key points covered in the book. As we reach the culmination of our exploration into the remarkable world of artificial intelligence, it's essential to take a moment to reflect on the key points that have been brought to light throughout this book. We embarked on this journey with an introduction to the rising prominence of AI in our modern world. Understanding the impact and workings of AI has become critical in 2023, as it infiltrates every aspect of our lives, from the workplace to our homes. The story of AI began in Chapter 2, where we traced its fascinating history from the groundbreaking ideas of Alan Turing to the bleak period known as the AI winter. Its resurgence owes much to advances in machine learning, neural networks, and an endless procession of breakthroughs that have sometimes outpaced society's capacity to integrate and understand their implications fully. In Chapter 3, we grappled with the fundamental concepts that are the gears and pulleys of AI, including machine learning, deep learning, and neural networks. Terms like natural language processing and computer vision were demystified, and we explained how robotics meld with AI to create systems that can act autonomously. Chapter 4 took us deeper into the technosphere with a tour of AI technologies and frameworks. Recognizing the multitude of tools at the disposal of developers is crucial. Hence, we considered the strengths and weaknesses of both open source and proprietary AI solutions, and pondered the way AI is weaving itself into cloud services and existing technology stacks. The versatility of AI was put on full display in Chapter 5, as we turned our focus to industry-specific applications. AI has left an indelible mark on healthcare, finance, retail, manufacturing, education, and entertainment, to name just a few. The examples provided here serve as a powerful testament to AI's transformative potential. Ethical considerations, often overshadowed by technological enthusiasm, were given their due attention in Chapter 6. We tackled pivotal issues like bias, transparency, privacy, and the future of employment in the context of AI. The necessity of sound governance and regulatory foresight was underscored as we navigate these uncharted waters. In Chapter 7, the criticality of data as the lifeblood of AI was emphasized. We covered how data is collected, managed, processed, and protected within AI systems. The role of big data was presented not simply as a buzzword, but as an intricate tapestry of information that AI relies upon to learn and evolve. Chapter 8 peeled back the curtain on the behind-the-scenes world of AI development and lifecycle management. AI projects are complex and require meticulous planning, a robust team, and an adherence to a structured development process. Testing and maintenance were highlighted as vital to the success and longevity of deployed AI systems. Our societal lens in Chapter 9 afforded us a view of AI's broader impacts beyond the economic and functional, exploring how AI is shaping social good initiatives, public perception, governance, and policymaking. Finally, Chapter 10 proffered a glimpse at what likely lies ahead for AI, predictions for future developments, the evolving role of quantum computing, and the entwinement with other emerging technologies set the stage for what promises to be an exhilarating future. 13.2. The continuous learning journey of AI. Artificial intelligence is not a field that rests on its laurels. It is in perpetual motion, always learning and improving. Those at the forefront of AI, researchers, engineers, and enthusiasts alike, share a commitment to nuances of neural networks, comprehend the complexity of computer vision, and anticipate the amalgamation of AI in daily life. 1.9 Parting words before we begin. As we stand on the threshold of an AI-augmented era, the importance of broadening our understanding of this discipline cannot be overstated. It is a pursuit that is shared across national borders, academic disciplines, and industry sectors. With this comprehensive introduction, we open the curtains to a stage that will see the continued convergence of human intellect with artificial ingenuity. This journey is not just about intelligence. It's about our collective future and how we choose to shape it. Welcome to the AI Ascendance, where the future doesn't just unfold, we help design it. Chapter 2. History and Evolution of AI. 2.1. The Early Days of AI, from Turing to the AI Winter. The journey into artificial intelligence, AI, is, in essence, a human quest for transcendence, an endeavor to harness the computational prowess of machines to replicate, complement, and exceed human cognitive abilities. The conceptual framework for AI was initially set out by legendary British mathematician Alan Turing. In 1950, Turing proposed the famous Turing test as a measure of a machine's ability to exhibit human-like intelligence, sparking interest and setting the stage for future research in the field. This era bore witness to a series of impressive developments marked by bursts of optimism. In the 1950s and 1960s, pioneering computer scientists like John McCarthy, who coined the term artificial intelligence in 1955, and Marvin Minsky forecasted that a fully intelligent machine would emerge within a generation. These AI pioneers developed the first programs that could learn checkers strategies, solve algebra problems, and prove mathematical theorems. However, the early excitement was dampened by unforeseen complexities. Initial ambitions failed to consider the breadth of the problem-solving nature of general intelligence. By the late 1960s, investment and interest waned as the limitations of these early AI systems became evident. This period of reduced funding and diminished expectations, from the mid-1970s to the early 1990s, became known as the AI Winter. High-profile predictions had gone unmet, and the public scrutiny that followed led to a retreat in AI research. 2.2. The Resurgence. Machine learning and neural networks. The fortunes of AI were rekindled through a transformation grounded in the very nature of approach. The shift from handcrafting explicit rules to enabling machines to learn these rules from data. This shift was powered by the advent of machine learning and, specifically, neural networks. A pivotal moment occurred in 1986 with the introduction of the backpropagation algorithm by Rumelhart, Hinton, and Williams, which revolutionized the training of neural networks. This algorithm efficiently adjusted the weights in a network by propagating errors backwards from the output layer to input layers. Thereafter, advancements in hardware, such as graphics processing units, GPUs, facilitated massive computational power that ushered in a new breed of deep learning models. Through the 2000s, datasets grew exponentially alongside the computational power required to process them, making deep learning not just viable, but impressively effective at tasks including image recognition, language translation, and even defeating human champions in strategic games like chess and Go. 2.3. Key milestones in AI development. Over recent decades, several milestones have defined the evolution of AI. In 1997, IBM's Deep Blue became the first computer chess program to beat a reigning world chess champion, Garry Kasparov. Google's AlphaGo left its mark on the history of AI when its deep learning-powered algorithms triumphed over the world champion of Go, Lee Sedol, in 2016. The development of general adversarial networks, GANs, in 2014 expanded AI's creative suite, Daemon, the ceaseless quest for knowledge. An aspect of AI that stands as both a challenge and opportunity is its inherent necessity for continuous learning. As we have uncovered, the learning journey of AI is intrinsically linked with our own. It is a reflective process where breakthroughs in AI push the boundaries of human knowledge and vice versa. The symbiosis between AI's evolution and our understanding is what will propel us forward towards a more intelligent and humane use of these systems. This book has laid out the complex landscape of AI, its intricacies, limitations, and boundless potential. Nonetheless, the true journey of AI is one that goes far beyond the pages of any single volume. It invites each one of us into a larger conversation, a universal effort to contribute to and shape the path AI will take in reshaping our shared world. 13.3. Final words of encouragement for AI adopters. To those who stand on the brink of AI adoption, whether in business, academia, public service, or personal curiosity, let this book be both your inspiration and practical guide. I encourage you to approach AI with judicious optimism. Engage with AI not just as a tool to be used, but as a partner in co-creating a future that reflects our shared values and aspirations. Be aware of the ethical implications, advocate for transparency and fairness, and remain conscientious stewards of the powerful technologies at our disposal. For businesses, integrating AI could mean the key to unlocking unprecedented efficiency and innovation. For individuals, it presents a pathway to a deeper comprehension of the complex systems that govern our lives. And for society, the thoughtful deployment of AI could help solve some of our most intractable problems, from climate change and healthcare to education and inequality. Let us remember, the story of AI is not a narrative of machines taking over the roles of humans, but rather humans leveraging machines to enhance and amplify our innate capabilities. Adopting AI involves a learning curve, but fear not the challenge it poses. Instead, regard it as an open invitation to participate in the next stage of our collective growth and advancement. In closing, embrace AI responsibly and with an open heart and mind. The horizon of possibility stretches out before us, and it is teeming with potential. By paying heed to the lessons outlined in this book and continuously seeking new knowledge, you stand to not only participate in the future shaped by AI, but to actively shape it towards a preferred destination for the benefit of all. Let the dialogue continue, and may your journey through the endless frontier of artificial intelligence be filled with insight, creativity, and unwavering commitment to the common good. Strated by systems that could generate hyper-realistic images. Another significant advancement came with OpenAI's GPT-3 in the area of natural language processing, capable of generating coherent and contextually relevant text. These technologies are indicators of an accelerating pace of AI progress. 2.4. Case studies. Successes and failures in AI evolution. Our understanding of AI is also deeply informed by examining case studies across various periods of its development. Successes such as IBM Watson's victory in Jeopardy! In 2011 showed the potential for AI in natural language understanding and processing. AI has proliferated in various sectors, from the simplicity of spam filters to the complexity of autonomous vehicles. Conversely, failures provide critical insights. One prominent example was IBM Watson's venture into oncology, where it struggled to apply its capabilities to healthcare. A testament to the challenges AI faces in complex, real-world applications. Other notable failures stress the limitations of AI. Microsoft's AI chatbot Tay, which learned from Twitter conversations, turned into a PR nightmare as it began to spout offensive statements, spotlighting concerns around AI's susceptibility to being influenced by data biases. In both successes and failures, the essential narrative stays consistent. AI development is a function of ambition, harnessed by the pragmatic realities of technology, data, and societal implications, paining them for optimized integration with various cloud platforms. This integration, critical to businesses and developers, not only scalably supports AI models' life cycles, but also broadens the reach and accessibility of AI technologies. As this historical account paints the undulating narrative of AI development, the philosophies, tools, frameworks, and systems have seen ebb and flow, inevitably climbing an arc of progress each time. By understanding where AI came from, it becomes clearer to navigate where it is headed, a quest that flows through the present and into the future of ubiquitous computation and operational intelligence to sectors from home automation to interstellar exploration. Through a thoughtful exploration of where AI began, the paths it navigated, and where it stands today, we can better understand how to shape its journey forward, responsibly and effectively. With the drive to create increasingly sophisticated forms of AI, the continuing narrative of artificial intelligence will remain one of the defining sagas of the 21st century and beyond, mingling existential questions with technological wonder. Chapter 3: Fundamental Concepts of AI. 3.1 Understanding Machine Learning. At the heart of artificial intelligence is machine learning. This concept refers to the ability of machines to learn from data, identify patterns, and make decisions with minimal human intervention. Machine learning encompasses various algorithms and techniques that allow computers to improve their performance on specific tasks over time. The procedure starts with feeding the system large amounts of data, which may include numbers, words, images, clicks, and other forms of information, depending on the task. These datasets are used to train models, which are essentially functions that map inputs to desired outputs. For instance, in spam detection, the model would be trained to distinguish between spam and non-spam emails. As the machine processes this data, it learns to recognize the characteristics that define each category, improving its ability to correctly classify new examples. One key aspect of machine learning is generalization, which is the model's ability to perform well on previously unseen data. Generalization hinges on the model's structure and the quality and diversity of the training data. Machine learning models need to strike a balance between being flexible enough to fit the nuances in the training data, referred to as underfitting, and not so flexible that they mimic the noise in the data, overfitting. 3.2 Deep Learning Explained. Deep learning can be thought of as a subset of machine learning, although over recent years it has become nearly synonymous with AI due to its staggering successes. It utilizes multi-layered neural networks to process data in complex ways, enabling the recognition of highly abstract features. This approach has been paramount in making significant strides in areas such as image and speech recognition. In deep learning, neural networks consist of multiple layers, where each layer transforms its input data into a slightly more abstract and composite representation. Consider an example with image processing. The initial layers of a neural network might only recognize edges or colors in an image. Intermediate layers might understand textures or shapes, and the deepest layers might identify objects like cars, trees, or faces. This hierarchical learning process mimics how human brains are believed to work, and gives deep learning networks the capability to handle very complex tasks. Training deep learning models requires substantial computational resources and massive sets of data. These models use techniques such as backpropagation to fine-tune the internal parameters that weigh the importance of different features in making accurate predictions or classifications. 3.3 Neural networks and how they work. Building upon the foundation laid by deep learning, we delve into neural networks, the architecture driving this capability. Neural networks are composed of nodes, or neurons, that are interconnected and arranged in layers. The input layer receives the raw data, and the output layer provides the final decision or prediction. In between are hidden layers that perform intermediate computations. The individual neurons in these layers are essentially simple processors that perform a weighted sum of their inputs and then pass this sum through a nonlinear function, also known as an activation function, to produce an output. The beauty of neural networks is that by adjusting the weights and biases through training, they can model complex, nonlinear relationships between inputs and outputs. 3.4 Natural Language Processing, NLP. A field within AI that deserves special mention is natural language processing. which equips machines with the ability to understand, interpret, and generate human language. NLP combines computational linguistics with machine learning to process and analyze large amounts of natural language data. Some everyday applications of NLP include language translation services, chatbots, and virtual assistants like Siri or Alexa. Core tasks of NLP range from simple ones like tokenization, where the text is broken down into words or phrases, to complex operations like sentiment analysis and machine translation. Advanced NLP systems even capture the nuances, irony, and humor in human language, making interactions with machines more natural. 3.5. Computer vision and pattern recognition. A significant leap forward in AI has come through the development of computer vision. This field gives machines the ability to understand and interpret visual information from the world. By using digital images from cameras and sensors and deep learning models, computers can accurately recognize and classify objects and, in certain cases, respond to what they see. Pattern recognition is at the core of computer vision. It involves the identification of regularities in data, such as the distinctive features or shapes of a face that allow facial recognition software to identify individuals. Pattern recognition systems can learn from labeled examples, just like other machine learning methods, and have vast applications ranging from medical diagnosis to the identification of trends in financial markets. 3.6. Robotics and AI. Linking AI to the physical world is the domain of robotics. AI fuels the brain of robots, allowing them to perform complex tasks that require adaptability and decision-making abilities. While traditional robots could only perform repetitive tasks in controlled environments, AI-driven robots can navigate dynamic and unstructured spaces, such as warehouses, natural terrains, and even domestic settings. AI in collaboration with robotics has enabled the creation of autonomous vehicles, drones that can monitor crops, and personal assistants that can help with daily tasks. The integration of AI in robotics represents a blend of cognitive intelligence with mechanical prowess, signifying a substantial leap beyond predetermined programming towards a more adaptive and sophisticated machine behavior. In summation, understanding these fundamental concepts of AI is crucial. Machine learning serves as the foundation upon which deeper and more complex systems like neural networks are built. These in turn power specialized fields such as NLP and computer vision. Robotics merges AI's cognitive capabilities with tangible actions, showing the potential that AI has to reinvent the way we connect with machines. As we march forward, these foundational concepts will not only shape the future of AI, but more profoundly, the evolution of technology at large. Chapter 4 and Framework 4.1. Overview of AI technologies. Artificial intelligence. Technologies have become an intrinsic part of the digital ecosystem, reshaping the landscape across various fields and industries. We've transitioned from a period of passive acceptance of algorithms to actively seeking AI to better our decisions, optimize processes, and unlock insights from data. But what exactly comprises AI technologies? At its core, AI technology includes machine learning, including deep learning and neural networks, natural language processing, robotics, and knowledge reasoning, among other specialized fields. Machine learning, ML, for instance, enables computers to learn from and make decisions based on data without being explicitly programmed for every contingency. This has led to significant advancements in computer vision and predictive analytics, which can be seen in everything from medical diagnosis to self-driving cars. Natural language processing, NLP, allows machines to understand and interact using human language, powering virtual assistants and translation services. Emerging fields such as affective computing imbue machines with the ability to recognize and simulate human emotions, opening up new frontiers for human-computer interaction. Furthermore, exploratory areas like quantum AI, which combines quantum computing with AI algorithms, promises computational power unprecedented in classical systems. Understanding these technologies and their capabilities is essential to leveraging their potential in solving complex problems and creating innovative products and solutions. 4.2. Popular AI frameworks and libraries. As AI technologies have matured, so have the tools and frameworks that enable their development. These frameworks and libraries are crucial for researchers and developers, as they offer pre-built functions and structures to outline and expedite AI-related tasks. TensorFlow and PyTorch stand out as heavyweight champions in AI neural network training, backed by Google and Facebook respectively. TensorFlow is renowned for its flexibility and comprehensive ecosystem, being deployed across numerous devices and platforms. PyTorch shines with its intuitive syntax and dynamic computational graph, making it a favorite amongst research and academia for allowing easy alterations during the model building process. Scikit-learn is another workhorse, especially for those deploying classical machine learning algorithms. Known for its simplicity and accessibility, it garners widespread use in academic and commercial circles for conducting straightforward tasks. For NLP, libraries such as NLTK and Spatie offer tools for processing and understanding text, whereas OpenCV is a go-to for real-time computer vision applications. These are supported by numerous other auxiliary libraries like Keras, a high-level neural network API, which can run on top of TensorFlow, allowing rapid prototyping, and Pandas for data manipulation, which have become integral in the hands of data scientists and ML developers. 4.3. Open source versus proprietary AI tools. The debate between open source and proprietary AI tools delves into considerations like cost, community support, flexibility, and control. Open source AI tools such as TensorFlow, PyTorch, and others provide the user with a high degree of customization with a community-driven approach. They encourage collaboration, allow for peer review and bug fixes, making them hotbeds for innovation and knowledge sharing. Moreover, they tend to be free, which can be beneficial for startups and educational institutions working on a tight budget. Proprietary tools, on the other hand, are developed and controlled by one organization, often providing a sleeker, more user-friendly package, inclusive of customer support and regular updates. They tend to emphasize on security and integration capabilities within certain ecosystems, which explains their preference within certain enterprise contexts. The choice often depends on the specific needs, strategic objectives, funding, and the expertise available to a team or organization regarding the development and implementation of AI projects. 4.4. Cloud AI services. Cloud AI has democratized access to powerful AI capabilities. Cloud service providers like AWS, Amazon Web Services, Microsoft Azure, and Google Cloud have abstracted much of the complexity involved in setting up and scaling AI initiatives, offering AI services through the cloud. These services include pre-trained AI models for various tasks like speech recognition, translation, and image analysis, along with tools that allow companies to train their own models using cloud-hosted data and compute power. The scalability of cloud AI allows not only large organizations but also small firms to incorporate advanced AI into their products without huge upfront investments in hardware and infrastructure. Moreover, these platforms constantly evolve, integrating cutting-edge research and AI developments into their service stack. Consequently, enterprises that adopt cloud AI services can often stay at the forefront of technological advancement with minimal in-house R&D. 4.5. Integrating AI into existing technology stacks. Integrating AI into existing technology stacks is something that most companies need to confront eventually. This integration often involves both strategic decisions about where AI can add the most value and technical decisions about adapting current systems to function with AI technologies. This process can be challenging, necessitating careful planning, re-evaluation of data infrastructure, and potentially training staff or hiring new talent. However, the underlying goal is to ensure that the AI component works seamlessly with the existing systems. Enhancing functionalities like customer relationship management, real-time analytics, or operational efficiency, rather than siloed away or tacked on as an afterthought. For a successful integration of AI, developers often utilize APIs, application programming interfaces, to connect different components without extensive changes to the base system. Middleware designed for AI can also facilitate the communication between AI models and legacy systems, ensuring that insights generated by AI are utilized effectively within existing business workflows. In writing this chapter, we hope to impart a clear understanding of AI technologies and frameworks that form the backbone of current and future AI applications. Whether it's choosing the right framework, navigating open source versus proprietary tools, leveraging cloud AI services, or integrating AI within current systems, these choices shape the potential impact AI will wield across industries and sectors. Chapter 5: AI in Industry. The sprouting of artificial intelligence capabilities across various industries has triggered a wave of transformations, exceptional not only for their pace, but their breadth and depth. Industries reflecting this technological revolution range from healthcare to finance, and from education to entertainment, shaping a future where AI is an integral part of every sector. In this chapter, we will explore the various applications of AI across multiple industries, understanding how its adoption is revolutionizing operations, enhancing efficiency, and creating opportunities for innovation and improved customer experiences. Chapter 5: Industries and AI. 5.1: Healthcare and AI. AI's incursion into healthcare heralds a new era of diagnosis, treatment, and patient care. Machine learning algorithms are adept at pattern recognition, making them highly valuable in diagnosing diseases from imaging scans or predicting patient outcomes from historical data. For example, AI systems have shown a remarkable ability to detect retinal diseases and skin cancers with accuracy comparable to human experts. IBM's Watson, for example, assists in unraveling complex medical data and generating insights into treatment plans tailored to individual genetic profiles, personalizing healthcare like never before. The power of AI in healthcare extends to patient monitoring and care, with wearable devices using algorithms to alert users and doctors about potential health issues, thereby facilitating proactive healthcare management. Furthermore, during pandemics, AI has played a pivotal role in speeding up vaccine development and managing patient loads in hospitals through predictive analytics. 5.2: AI in Finance and Banking. The financial sector witnesses a profound impact of AI, which enhances both customer-facing and back-end operations. Chatbots and virtual assistants provide 24/7 customer service, handling queries with increasing sophistication. AI's real prowess shines in fraud detection and risk management. By scrutinizing transactional data in real time, AI systems can flag unusual activities, reducing the likelihood of fraudulent transactions slipping through the net. Additionally, robo-advisors are upending traditional asset management techniques, offering algorithmically driven financial planning services and investment advice, thereby democratizing access to financial expertise. AI is also instrumental in credit scoring, offering more nuanced assessments than traditional models. These AI systems can incorporate a wider range of data, from spending patterns to web browsing behavior, to extend credit to individuals who might be overlooked by conventional banks. 5.3: Retail and Customer Service AI Applications. Retail is another domain where AI is making a notable mark. AI-driven recommendation systems on e-commerce platforms, like those used by Amazon, personalize the shopping experience, driving sales and customer satisfaction. In physical stores, AI aids in managing inventory and predicting trends to optimize stock levels. Additionally, AI technologies like computer vision are used to create cashier-less stores, where customers can simply grab items and go, as their accounts are automatically charged. Customer service has been transformed by AI's capability to assist or even replace human representatives during the initial stages of customer interaction. Automated responses to queries, order updates, and tracking information are standard now, while more sophisticated AI can engage in complex interactions, learning from each exchange to improve its performance. 5.4: AI in Manufacturing and Supply Chain. AI has introduced substantial efficiencies in manufacturing and supply chains, embracing the concept of smart factories, where AI-driven robots and IoT devices streamline operations. Predictive maintenance approaches, powered by AI, anticipate equipment failures and schedule timely repairs, thereby minimizing own time. Supply chain optimization has perhaps seen one of the most impactful applications of AI. Algorithms analyze vast arrays of logistics data to optimize routes, inventory levels, and delivery schedules, accommodating real-time changes in demand or supply disruptions. This not only saves time and costs, but also contributes to more sustainable practices by reducing waste and excess emissions. 5.5. The role of AI in education. Educational technology utilizes AI to personalize learning and open up new frontiers for adaptive learning platforms. Such systems can gauge a student's current level of understanding, preferred learning pace, and style, adjusting instruction accordingly. Furthermore, AI in education extends outside the classroom through the automation of administrative tasks, freeing educators to focus more on pedagogy and less on paperwork. AI's analytical prowess also proves invaluable in identifying gaps and biases in educational content and approaches, paving the way for more inclusive curriculums. 5.6. AI in entertainment and media. The advent of AI in entertainment and media industries has transformed content creation, distribution, and consumption. Music and video streaming services utilize AI to curate content personalized to individual preferences. In movie production, AI tools assist in everything from scripting to visual effects, and even predicting box office success. AI also personalizes advertising, ensuring that marketing campaigns reach the most receptive audiences, and utilizes sentiment analysis to gauge audience responses to content in real time, offering an unprecedented level of feedback and interaction. With AI's roots growing deep into the soil of various industries, the transformation of economic landscapes has become undeniable. As we address these sector-by-sector evolutions, it is crucial to understand that AI's potential is universal, touching the lives of individuals and societies globally, and crafting tales of success driven by unmatched speed, accuracy, and efficiency. Chapter 6. Ethical Considerations and AI. 6.1. Bias and Fairness in AI. The swift acceleration of AI development has brought with it critical concerns pertaining to bias and fairness. In essence, AI systems learn from data, implying that the data's inherent biases can lead to discriminatory outcomes. From facial recognition software exhibiting prejudice against certain ethnic groups, to credit scoring algorithms that unintentionally marginalize low-income communities, the spectrum of AI bias can be widespread and severe. The genesis of bias often traces back to historical data, wherein societal prejudices are insidiously encoded and transferred to AI models. For example, if an AI hiring tool is trained on data that includes a history of underrepresenting women in leadership roles, it may inadvertently propagate this pattern, deeming male candidates to be more suitable for executive positions. Addressing these biases demands meticulous examination of training data, along with continuous monitoring of AI predictions. Strategies like blind data techniques and fairness-aware machine learning can significantly mitigate unsuspected biases. Despite efforts, total eradication of bias persists as an elusive goal, perpetuating the critical need for humans in the evaluation loop to ensure equitable decision-making processes. 6.2. Transparency and Explainability. A closely correlated sphere to ethical AI is its transparency and explainability. The black box nature of many AI models poses a conundrum where decisions made by an AI system are impenetrable to its users, leading to trust issues. Explainable AI endeavors to make the decision-making processes of AI systems understandable to humans, both on a technical level to developers and on a practical level to end users. The strides in explainability relate to the ability to scrutinize and interpret AI processes, justifying specific outcomes and enabling the identification and correction of hidden biases. Tools and frameworks such as LIME, Local Interpretable Model Agnostic Explanations, and Shapley Additive Explanations, have emerged to demystify the operations of complex models. Transparency also relates to openly communicating an AI system's capabilities and limitations, setting realistic expectations. To foster trust and acceptance, stakeholders require clarity on how AI systems work and the rationale behind their decisions. 6.3. Privacy concerns with AI. The invasive potential of AI in compromising individual privacy is a pressing ethical issue. With the burgeoning proliferation of data, AI algorithms can now identify patterns and personal details that were once considered anonymous. This has stoked fears regarding surveillance, data misuse, and the loss of autonomy over personal information. Legislation such as the European Union's General Data Protection Regulation, GDPR, enshrouds individuals with greater control over their personal data, with repercussions for global AI practices. Nonetheless, conflicts continue between the voracious data appetite essential for advancing AI and the sacrosanctity of personal privacy. Technological safeguards like differential privacy, which adds a level of noise to the data to preserve individual privacy, and federated learning, which trains algorithms across decentralized devices, are novel attempts to uphold privacy. Combination of such techniques with stringent data governance policies is the anticipated route to balancing AI's thirst for data with individual privacy rights. 6.4. AI and employment. The future of work. AI's impact on employment paint a dichotomous picture. While AI adoption may lead to job displacement due to automation, it also brings forth opportunities for new job creation and augmentation of existing jobs. The shifting employment landscape implies that workers will need to adapt, with upskilling and reskilling becoming paramount in the future labor market. Sectors involving routine or predictable tasks are susceptible to automation. On the other hand, professions that necessitate human intuition, creativity, or intricate manual dexterity likely pose a challenge for AI to replicate. Stakeholders, including governments, educational institutions, and businesses, all share the responsibility for cultivating a workforce that can thrive alongside AI. The transition should facilitate not just technological acumen, but also foster those soft skills where human workers are anticipated to hold an enduring advantage. Moreover, fostering a symbiosis of AI and human talents can lead to higher productivity and job satisfaction when orchestrated properly. 6.5. Regulation of AI governance and regulation of AI are vital considerations as its influence escalates across all societal and industrial facets. The regulation of AI flirts with the delicate balance of stimulating innovation while thwarting potential misuses and harm. Society's grasp for regulatory frameworks that would dictate ethical principles, establishing guardrails for the deployment and functionality of AI systems, such as minimizing harm, ensuring safety, and promoting societal welfare. Leading entities, including the European Union, the United States, and China, have embarked on drafting guidelines and laws tailored towards the secure and ethical proliferation of AI. These provisions span a breadth of aspects, including data privacy, transparency, explainability, and accountability. Ensuring global cooperation is crucial as AI systems transcend borders. Disparities in regulation may lead to forum shopping, where companies might operate extensively in regions with lax AI regulations, potentially undermining global efforts to ensure ethical practices. As we navigate the AI era, extending our competence beyond the technical facade to encompass ethical dimensions becomes imperative. Steered conscientiously, AI holds the key to unlocking an era of egalitarian now. That concludes the AI Ascendance. The era of neo-intelligence begins now. A deep dive into AI in 2024 by Roni Everleaf and narrated by Benjamin K. Shillings. This has been an Intercontinental Digital Matrix Publishing audiobook. Thank you for listening. God bless America and long live the King.